Today we're talking about decimal place value. I want you to take a minute and look at this decimal place value chart and see what you notice. I see that they have taken the number 25 and 427 thousandths and broken it down each digit into its place value. So in the tens place we have a 2, in the ones place we have a 5, and those are both whole numbers. Now getting into the decimal, in the tenths place we have a 4, so we have 4 tenths. If this was money, that would be like having 4 dimes, since a dime is a tenth of a dollar. In the hundredths place, we have a 2, so we have 2 hundredths. If this was money, that would be like having 2 pennies, because there are 100 pennies in $1. And then finally, we have the thousandths place, and we have 7 thousandths. Now, we don't have a coin for a thousandth of a dollar, so that's kind of where the money example stops. But you would read this number as 25 and, you'll notice I wrote the word and, so whenever you get to the decimal point, that's that little period, you say the word and, 25 and 427 thousandths. So to the left of a decimal point, we have our whole numbers, and to the right of our decimal point, we have the decimal values. Those are numbers less than one whole. In 5th grade, we're going to represent decimals using base 10 blocks or models quite frequently, so a visual representation of a decimal amount. We refer to this big rectangle, the whole thing, as a flat, and a flat represents one whole. So this whole big rectangle represents 1. It's divided into 10 equal size pieces, and we call these rods or longs. So one of these vertical pieces we call a long or a rod, and it is 1/10 of a whole. So if I wanted to represent the decimal 4 tenths, so you can see there's a 0 in the ones place because this is a number less than 1, and we have 4 tenths, that means that I would shade in 4 longs because each one of these is worth 1/10 of a whole. If this was money, this would be like having 4 dimes because a dime is 1/10 of a dollar. If you were to represent this in word form, that's just writing the words that match how we say this, so that would be 4 tenths, or as a fraction, 1/10. Now, a lot of kids might read this as 0.4. It's not wrong. Many people say decimals that way in the real world, but for our purposes, we're always going to try to use the most mathematical verbal representation of a decimal, which in this case we would say this as 4 tenths. This next decimal model represents 73 hundredths. You can see we have a 7 in the tenths place. We have 7 longs shaded in. And then a 3 in the hundredths place. We represent hundredths using these, we call them cubes, and each one of these tiny little squares or cubes is 1/100th of a whole. I want you to just take a second and see what you notice, see if there's any patterns that jump out to you, and we'll come back together in just a minute. So some people, it helps to think of decimals as money, and in this case, if this was a dollar amount, we would have 73 cents or 73 hundredths of a dollar. You can see that 7 longs or 7 tenths have been shaded in, which matches the 7 in the tenths place. And then we have a 3 in the hundredths place, so 1, 2, 3 hundredths have been shaded in. If each one of the little cubes is 1/100th of one whole, then that's like having 73 cents. So you could count, it would take a while, but you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. And you should count 73 of these little cubes shaded in, which you would. The last two decimal models we looked at represented amounts less than one whole. On this page, you'll see two different sets of decimal models that represent amounts greater than one whole. And in this case, we're dealing with money, $3.60, $3.47. Now remember that each flat, that's each large rectangular square, represents one whole. So to represent $3.60, you can see one flat, plus another flat, plus another flat. So that's our $3. That's our whole number amount to the left of the decimal. And then finally, to represent the 60 cents, that's like having 6 dimes or 6/10 of a dollar, you can see the 6/10 or 6 longs shaded in. See if you can make sense of the next one, $3.47. So we have one whole dollar, plus one whole dollar, plus one whole dollar. That's the 3 in the ones place, or the whole number value to the left of the decimal. And then we have 47 hundredths, or 4/10, and 7 hundredths shaded in the final flat, for a total of $3.47. On this last page, you can see how I've represented the decimal 4 and 38 hundredths 4 different ways. The first way is in word form. That's just writing out the words that match how I would say this decimal. So 4 and, that's the decimal point, 4 and 38 hundredths. Next, you can see this decimal represented in expanded form. So like we learned about earlier this week, that's just representing the value of each digit. So we have a 4 in the ones place, so that's 4 ones or 4. We have a 3 in the tenths place, so that's 3 times 1/10 or 3/10. And then finally we have an 8 in the hundredths place for a total of 8 hundredths. You can break it down further into expanded notation, which is really just writing out what I said. 4 ones or 4 times 1, 3/10 or 3 times 1/10, plus 8 hundredths or 8 times 1/100th. And then finally you can see I've drawn, we call these a quick picture that represents how we would represent a decimal with base 10 blocks or decimal models. So I have 4 flats, 1, 2, 3, 4, and if you add those together, each one of those represents one whole. That's our 4 in the ones place. And then I have 3 longs, 1, 2, 3, and that represents the 3/10 we have. And then finally, these are like the little cubes. We have 8 of those, and those are 8 hundredths. And if we were to add all of these together, 4 plus 3/10 plus 8 hundredths, we would get a total of 4 and 38 hundredths. And you can see the same pattern with this last decimal, 135 and 76 thousandths. So first I've written it out in word form. Again, when I get to the decimal point, that's where the and symbol comes in. So 135 and 76 thousandths. Then I've broken it down into expanded form, which just shows the value of each digit, and then expanded notation. See if you can make sense of those.